Hello, I'm Clover, and this is Gas. Today we're solving The Old Fortress by Philip Newman. This is a fortress Sudoku, so we have normal Sudoku rules, placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And then also we have some fortress cells in the grid. So the digit in a fortress cell has to be greater than the digits in all white cells that are orthogonally adjacent to it. So for example, these two cells have to be 8 and 9 because those are the only two digits in Sudoku that are greater than 7. These have to be some combination of 7, 8, and 9. Of course that can't be 8 because there's now an 8 in a row. And these, because they're all greater than 5, have to be some combination of 6, 7, 8, and 9. We can make a couple of eliminations just based on what we already have in our rows and columns. Now if we look across this row, this is a 6, 7, 9 triple. We know that the 6 is in one of these two cells, definitely, because it's not here. Therefore, this can't be our 6, so that's going to be an 8. And we can't necessarily figure out anything else from that. This is going to be either a 7 or 9 because it's greater than 6 and it's not 8. This is a 9 because it's greater than 8. So that's going to take care of this. That's going to make this into a 6, 7 pair and give me a 9 here. And reduce this to a 7, 8 pair. Now what's greater than 5 other than 7? We also have 6, 8, or 9. 9 already appears in the row. Okay, now 3 is greater than only 1 and 2. And 5 is greater than 1, 2, 3, and 4. So that's not 1 or 3. Oops, I can eliminate 5 from there. Those are not 2, that's not a 1, and that's not a 4. And 4 is greater than 1, 2, and 3. That can't be our 2. So 4 is definitely in one of these cells because we have this 1, 3, 4 triple here. And out of that triple, the 4 is definitely in one of these two. So that's definitely going to be a 2 right there. Okay, now finally our last fortress cell that we haven't really accounted for is this one. And I believe that that has to be a 9 because we have 9s here and here and a 9 there, so that rules 9 out of those cells, and 9 can't be here because 9 can't be less than whatever goes in this cell, so that's going to be a 9. And I think that basically accounts for all of our fortress cells, so we can go ahead and start working on some Sudoku and then hopefully reduce a few of these fortress clues further. So we have a 7, 8 pair here, so the digits 7, 8 in this region have to go into these two cells, and our remaining two missing digits 6 and 9 have to go there. So now these are 2, 3, 4, and 5, okay. Now if we're looking at this row across here, these can only contain 1, 2, 3, 4, and 5. We can make some eliminations here because these are a combination of 1, 2, 3, and 4. In fact, 2 and 3 are in this column already, so that's a 1, 4 pair. And then this is going to be a 2, 3 pair. And then these remaining digits are 5, 6, 7, and 8. This cannot be a 7 or an 8, so that is a 5 or a 6. Oh, and there's a 2 here, so that's not going to be a 2. Okay then. So what next? I'm wondering if we can make some progress with 9s potentially. 9 has got to be in one of these cells. No, I don't think we can really say a lot about where 9 has to be. 9 has to be in one of those cells. Yeah, I'm not sure that that's going to simplify things for us. How about this central column? So the remaining digits that we haven't identified yet are 1, 2, 3, and 8. So this is 1, 2, or 3. This certainly can't be an 8 because it can't be next to a 4. So that's also going to be 1, 2, or 3. In fact, it's 1 or 3 because of the 2 there. So that makes this a 2, which resolves the 2, 3 pair. And then that's where my 8 is going to go in the column. So that's now a 7 and an 8. And this is not an 8. Okay. These cells are going to contain 5, 6, 7, and 9. Those aren't 5s. Those are not 7s because there's a 7 in the row already. Those are not 9s. Alright, perfect. Now what? Okay, I need 1, 2, 3, 4, 5, 6 in this row. And I know that was a bit of messy pencil marking, but I'm going to go ahead and reduce it. Those can't be 5s. And I don't think I can simplify that a lot from here, actually. So where are we going to go now? This is really a little bit of a tricky one. We'll figure it out. Where can we put 8 in this region? 8 could go here, or it could go there. That's not really going to help me out a whole lot. How about this row? I have 5, 6, 7, 8, 9, so I need 1, 2, 3, and 4, and those can't be 2, and that also can't be 2 because of the 2 in the row. So this is going to be a 2. And that's going to be 1, 4, and 5. That's going to be a 6. And these are going to be 1, 3, 4, and 5. 4 is in one of those cells because of the 1, 3, 4 triple here, so these cannot be 4s. And then my remaining digits in this column will be 6 and 7, leaving these in the region as 2, 3, 4, and 5. And those can't be 2, so therefore there's only one position for 2 in the region. It's there. And now there's only one position for 2 in the central region, which is right there, and that leaves us with one position for 2 in this region. And I think that places all of the 2s in the entire grid. Fantastic. Okay. So where are we going to go from here? So we can no longer place an 8 here because that would make it lower than 6 in this cell. So 8 definitely has to go in this cell, which is going to make this a 7 and make this an 8. And so this can no longer be a 7. And so there's only one position for 7 in this region in the bottom center. It is right here. This is a 5, 6, 9 triple, so I need to place a 4 to finish off the row, and that's not a 4. Okay. And these are 5, 6, 7, 8, and 9. These can't be 8 or 9, so that's a 5, 6, 7 triple, except those also can't be 5. So there's my 5. 5, 6, 7, and 8. And now that's going to be a 6. And we eliminate 5, 6, and 7 from here. Eliminate 8 from that cell. And that region is resolved. Now we see we have a 9 in row 7. So it's going to be a 6. That's going to be a 9. This will now be a 9. Okay. This can no longer be a 6 because of the 6 right there. So this is a 3, 4 pair. This is not a 6. These are 1, 5, and 7. So there's a 7 there. That's not a 7. Okay, these cannot be 6s because there's a 6 now placed in the row. So now 6 in the region can only go there, which resolves the 6, 7. That was already resolved, actually, by the 7 right there. Oh well. 5 is in one of these cells, so that can't be 5. That's a 1. That places our 3. And a whole lot of stuff here is just resolved by Sudoku. That can't be a 3, that can't be a 3. Aha, this can't be a 3. And this whole region resolves. The 1 resolves this region. Those can't be 1s, so that's now going to be a 5 and a 1. That's a 4 and a 5. Cool. That's now going to be a 4, a 3, and a 4. It's now a 1 and a 3, a 4 and a 5, and a 1. That's a 1 and a 4. And that is how you solve Philip Newman's The Old Fortress, posted on December 13th, 2024. If you want to check that out yourself, the link to do so is in the description below this video. And I will see you again in 3 days.